In this video, we will learn about flow of electric charge and potential difference. We have already discussed that charges do not flow by themselves. They require some work or some effort is needed to be made on them to move the charges from one point to another. Therefore, for flow of charges in a conducting metallic wire, there must be a difference of electric pressure, and that difference of electric pressure is what we call as the potential difference. Now, to understand this concept, let us consider two analogies. The first analogy is based on the flowing of water. In this, we will first consider the flowing of water in a tube. So in this, first, we are taking a horizontal tube, that is both the ends are maintained at the same level. This is end A and this is end B. The water is being entered from end A, then the water will not reach end B automatically. Therefore, in this case, the water will not flow. But if the end A is maintained at a higher level, like this is end A and this is end B, and if the water is being entered from end A, now the water will flow from A to point B or end B. Therefore, the water will flow in this case. Now next, we are considering two beakers. The first beaker is beaker A, the second is beaker B. They both are connected by a channel, and initially this channel is blocked by a stop valve. Water in beaker A is maintained at a higher level and water in beaker B is maintained at a relatively lower level than beaker A. Now if this stop valve is removed, as the pressure in beaker A is higher, the water will move from beaker A towards beaker B, that is from higher pressure side to lower pressure side, like this. And it will move until the water in both the beakers are at the same level, like this. Thus, for flow of water through a tube, a pressure difference must be maintained between its two ends and the water flows from higher pressure side to lower pressure side. Now the second analogy is based on the flow of heat. In this case, we are considering two objects. This is object 1, this is object 2. Object 1 is maintained at a temperature T1 and object 2 is maintained at a temperature T2, and they both are connected. Now if the temperatures of both these objects are same, that is T1 is equal to T2, in this case there will be no heat flow. No heat flow. But if one object is maintained at a high temperature, let us say object 2 is maintained at a higher temperature, that is T2 is greater than T1. So now in this case, heat will flow. There will be heat flow in this case, and the direction of heat flow will be from object 2, that is object at higher temperature, towards object at lower temperature, that is object 1. Thus, for flow of heat, we must maintain a temperature difference and heat flows from higher temperature to lower temperature. So based on two analogies, we understand that for maintaining flow of electric charge, that is electrons along a conductor, we must maintain a difference of electric pressure, and generally this difference of electric pressure is what we call as potential difference. Thus, for maintaining a flow of charge, that is for a current flow through a conductor, potential difference must be maintained between its end, and positive charge flows from higher potential side to lower potential side. I hope this topic is clear to you. Thank you.